Hello and welcome. Here's an interesting question for you. Why some people who are practicing something for years or doing something for years and years on end are not acquiring great skills or amazing expertise in that domain? One of the obvious answers that come to mind is that they're not pushing themselves outside of their comfort zones or pushing themselves to the edge of their possibility and their knowledge and their expertise in a certain domain or area. That's one of the obvious answers, I would say. Another answer to that question would be the lack of high quality feedback loops. And that's the answer we're gonna explore in this video today and try to find out why on earth those things would be crucial for person's practice or skill growth. We will use some cool visual examples of nozzle production, evolution, golf, and thinking processes. So if you have some professional experience or you have done any activity in your life pretty much, you should have encountered the cases where the person with less time experience beats the person with more time spent in the industry or at a certain job. And when you look at the resumes of the candidates, sometimes the person with 1 year experience has more effective tools and ways and skill set to handle practical problems in a certain working environment comparing to the person who has 3 years of experience. And also another thing is that in certain areas or domains of expertise, people grow exponentially and are more likely to become masters of their craft. And in some other professions, they are not. They're repeatedly doing the same task and not growing any further than they are. They just maybe gain a little more in efficiency, but not going too far. So why is that the case, that people in the different industries progress better in certain professions? And the second one, why within the same profession, different people would progress faster than the other people, let's say? An answer to that would be that the people who have less time experience but more expertise, they have found or discovered more effective ways of learning and gain practical skills in the process. One of the components of effective learning or acquiring that skill would be building up high quality and high speed effective feedback loops. Why would that be the case? Here's the visual example for you that is quite fascinating to me. Imagine you're playing golf. You're driving to the range, to the golf course, and you start to hit the balls with your club. And you're concentrating and you're trying to get the technique down, and you're taking the shot, taking the swing. You're trying to figure out where the ball lands, comparing to where it has to land, where it has to go, and then you navigate. Next time you hit it, you try to get a little closer to that hole or to that spot where you want to hit it. And that's pretty much how practice happens in sports, by trial and error. So you hit, you miss, and then you adjust, trying to be closer to your end goal or to the position where you want the ball to land. Now, imagine you're not practicing in the daylight, you're practicing in the dark at night, like black pitch dark. And then you swing the ball, you hit it, and it lands somewhere. And then you hit it again, and it lands somewhere, right? You have no idea where it lands, or if it went way far to the right, or too far to the left, or too far ahead, or too close to you. You can practice for hours and years and 10 years hitting the ball in the dark, but if you don't know, if you don't see how the feedback goes comparing to your end goal, there's no chance that you would figure out how to actually play effectively and how to gain skill in that area. Think about being a chess player. When you make a poor move, you are instantly getting punished for that. And then you have to take your error and look at it critically and reconsider your assumptions and judgment and see how you were wrong and where, and build and adapt around that fact. So you're having constant feedback loop after you make a move, and then you get a feedback. You make a move, you get a feedback by your opponent punishing you or not punishing you for what you have done in the game. Another example with the fast feedback loops is driving. I learned how to drive last year, and that's having quite a quick feedback mechanism. Because if you spin the wheel a little too hard, the car goes too hard one side or the other, and you instantly get a feedback from your car that you are not doing a thing correctly. Or if you're doing something extremely stupid, then you might get punished harshly in that sense. So driving has a really quick feedback mechanism between what the action is and then what the feedback that is given by you on the road by that car. A good example of the deliberate practice activities would be something that can be done at high volume and that has a relatively fast feedback mechanisms towards what you're doing, and that those mechanisms or those feedback loops have to be constant, that are giving you constant feedback on what you're doing. Okay, so what would comprise a great feedback loop? There are three components. First is going to be quantity of the input and output, then speed of response, and the third one, harsh interaction with reality. And there are three stories or three concepts to explore that we can use them to touch on each of those components. First would be in the context of nature and evolution. Second one in the context of our thinking processes. And the third one in the context of the business and startup environment. So nature and evolution. How does nature or how does life wrestles with death, or how would constructive forces or creative forces of nature wrestle with destructive forces of this world, let's say. And it does it by creating a bunch of samples of the same organism with just a slight variation on each of those organisms, or a little tiny mutation or little adaptation difference between those. And then it basically puts it out there in the world and sees what survives. Then whatever survives, it procreates and it spawns another set of organisms of about the same kind with slight variation of that organism, and sometimes wild variations or mutations, but mostly slight. And then it sees what survives and thrives in that environment, in that geographical and temperature conditions that Earth creates. And then that's how basically our creative forces, let's say, battle the death in a way. So let's take a different example, a different world, so to say. Where do you think, as an adult, conscious human being, would you experience the most amount of feedback loops in your life? That's gonna be in your process of thinking. That's the most popular or the most common or the most primal feedback loop that we have for ourselves, so to say. So, what is thinking? Or why do we think? So we can act in the world. At least that's one of the answers to that question. So why not just act without thinking? Because you are going to harm yourself and others around you. So the thinking process is creating a representation of reality and separates that representation from the real behavior or real situation in the real world, and then we can manipulate that representation in our mind before we enact it or say something and act it out in the real world and do something really, really stupid, in a sense. So thinking process can be defined as creating little avatars of yourself, or spawning little different avatars of yourself, and those avatars or those little let's say personality, if you will, in a certain way, they stand in opposition to one another in the thinking process. So imagine a family setting that you're all sitting, and then you think that your cousin did something that, let's say, triggered you, or you thought it's bad, or you just generally don't like the person, and you have this thought appearing in your head, and you to say something that is gonna be addressed to that person, that is gonna ruin everything, everyone's evening in a way. And then there's another avatar of you that you've, let's say, created, says, oh no, this idea is not a great idea, it's gonna ruin everything today. And maybe there's a third avatar says, or first one says, okay, let's say something, but let's make it in a constructive way, and let's not make it public. Let's just have a private talk and do it in a way that the person is not going to get offended, but still going to get the feedback that is necessary. So those avatars or those positions or those entities, if you will, are opposing one another and have this little, let's say, dance or discussion, or different parts of you that have different opinions on a certain situation and how to act in that situation in a way. So, or you create different set of positions. Let's say you have a task, you are asking yourself a question, or someone else asks you a question of, let's say, what is an idea, right? To define the word idea for yourself. And you create this definition in your head that you think is an accurate definition for it. And then you try to figure out different universes or different situations when that definition is not going to work. So let's say you define the word and then you put a different word to it, like word thought or word concept, and you see, oh, my definition for the word idea actually matches the other words definitions, so it doesn't work. So basically create one universe where it works, one universe where it works, one universe it doesn't work. So it has to match, and you have to figure out what is the difference between the idea and the concept and the thought. So what differentiates those three? So you create an alternative to that thought, and you basically criticize yourself in a way. You make a definition and you criticize that definition, and you try to come up with a coherent and comprehensive definition for that word. And that's basically thinking process in a way of spawning different ideas or different personalities or different situations or universes are representations of reality, and then they contend between each other in a way. And same way thinking goes when it happens dialogically. So when you talk to your friend and you throw an idea out there and your friend tells how stupid that idea is, and you receive that feedback, you rethink it, and you create a different variation of that idea, and your friend does criticize it or take it or is trying to point out where that is not working, that is not applied. Oh, you start to rethink it, you spawn different variation of the same thing. So the concept of a feedback loop is that you're spawning those ideas in your head, or you're spawning those avatars or personalities or approaches or situations, and then you basically kill them off, and whatever the one that survives is the one that you vocalize and you speak out, or if it's an action, you take that action because you already walked it through your own internal feedback loop. And that feedback loop that you have for yourself is basically created by the set of experiences and preconditions and your prejudices and mindsets and all those biases that you have. Those create your internal feedback. And that's I would say, primal feedback mechanism that we all have and contend with. It's pretty quick in speed, but it lacks more important concepts that we talked about, is that interaction with reality that is not happening in the real world before you actually say it or you act that thought. But that feedback loop is probably one of the most important ones in our lives, because otherwise, if we wouldn't have that internal thinking feedback, then we would act and do something really outrageously bad. That would just hurt us and hurt others. That's another feedback mechanism. So feedback loops in our thinking processes are the most crucial ones for our survival. Otherwise, we wouldn't have been alive if we didn't have them. However, when it comes to the higher level of aiming and projects of great complexity, that can lead to detrimental results. Like in, let's say, small projects or young startups where, let's say, a founder or a person of, let's say, in the management position or an investor or whoever starts the initiative, they make an assumption, and rather a set of assumptions that something is going to work this way or that way or whatever, and then they create a product or service around that assumption. And one of the biggest mistakes of the companies, young companies like those and young projects, is that when the product is already developed and then there's a big release, then it flops hard. The project folds like a cheap suitcase because it didn't map the reality. So whatever the assumption that they had in hand did not match the reality in the first place. And even though everyone is already aware of this mistake, but it's still being made, it's probably one of the most common mistakes that people make when starting big and daring projects or businesses, for that matter. So Eric Ries, in his book Lean Startup, has covered this topic quite well, and I think it's one of the, let's say, good books out there as far as the topic goes. And he's talking about this idea of lean startup, which is basically fast and iterative business development process that is based on quick feedback loops in a way, or building hypotheses and testing those hypotheses against the reality, or building some prototype or some type of, let's say, basic business concept or basic product or MVP, minimal viable product, and then releasing that product to the customer base, to the users, to the audience, and then testing it and how it works, and then receiving quick feedback based on that, and do another iteration of the product, and then get feedback and iteration, and then rinse and repeat. And building startup like that, or any project, young project for that matter, is significantly decreasing the possibility of huge flop, because when there's a constant interaction with the customer base, you can see what it is really the customer needs in the end of the day, not what you think they would need. And there's a huge gap between those two, and it's a big difference in there that it can be derived from that simple thinking process in a way. No matter how smart you are, and there are extremely smart people out there in the in the world, they still make assumptions, and we hopefully we make assumptions of that contain huge errors within them. So no matter how smart a person is, they can still not predict all the twists and turns that the product development could take, and all possible features that the customers would interact with their unique experiences. So no matter how smart you are, and you cannot approach the process from all different angles and predict all sorts of things that might happen. No matter how hard you plan, no matter what magic things you do, there's still going to be things that you have not expected when it goes to public, let's say, and then public interacts with that product or service. Amazon has figured it out a long time ago with the huge data sets that they have access to, tons and tons of information, and they have genius level engineers who can play with that information and derive all sorts of conclusion and make all sorts of testing around that information. So let's say they have a button over here, so they can split test or A/B test and move it to a different position, or to move it to a different section, or to move it to a different tab, and then test it against multiple demographics and in different countries and in different time of the day, and in certain conditions, like let's say their holidays and their other celebrations and other periods. So they can just test that button and how that appearance or disappearance of that button in certain positions would influence all sorts of factors like customers' retention on Amazon website or an Amazon app, or clickability on certain items, or purchases for certain products, or overall in a certain stretch of time. Or they can change the color of their layout by a small degree and test it against those control group and then the group that they're testing it on. And then they just have this tab, and then this window opens. They can test all sorts of variations on tons and tons of different contexts and with different groups and demographics and level, let's say, purchasing levels. So they can manipulate that information, and with like trillion variations of how one can change things slightly, and then they can test how those little changes would influence those things, like, again, purchasing decision, customer retention, purchasing of certain products, clickability, watching advertisement, going through the link to Amazon Prime and then watch a movie, all those things, or order food or through the services that they have supplemental or partner with through their website. All those things, like trillion variations and trillion tests that one can do, and they do it at scale. So if you remember, we had this concept of feedback loops, and there are 3 important factors or qualities that the good feedback loop has. It's huge amount or big quantities of those loops. And then the second would be interaction with reality. And then the other is that they're getting fast, or the speed of the feedback, so to say. And they have all 3, and they have it at scale. So they can test all sorts of teeny tiny variation and see where it improves the customer retention by 0.0.1%, and then have another test and have another improvement by 0.1%, and then have 10,000 other improvements that increase it by 1%, and by 1% that is like an enormous amount of resource, and influence in a way, because, well, it just, those little percentages add up on top of one another with, and sometimes can bring exponential effects in that regard. One of the most fascinating examples of feedback loops, I've encountered it in the book called Black Box Thinking by Matthew Said. And I'm going to be paraphrasing, but the main idea is going to be pretty understandable, right? So he's telling the story of the company called Unilever. It's like Procter & Gamble, but in Europe, a company that produces all sorts of household, soap and washing liquids and washing machine powder and all those things. And I believe it was 1970s in England, they had this problem of creating the detergent powder. So the way it worked is that hot chemicals were put through the nozzle at high pressure levels and in high speed, and in the end of that nozzle, the chemicals cooled down and dispersed into vapor and powder. And that powder was used to mix with other chemicals and make the detergent that was packed and shipped, and the one that we use to clean, surfaces. So they had problems with that nozzle that the chemicals were going through because it kept clogging up and breaking down. It took quite a while, and it was fairly costly for Unilever to fix it. And also on the other side, when the chemicals went through, it produced those little sand or little granules of chemicals that were unequal in size. And it also, let's say, influenced the quality of the product negatively. And they had that problem. They tried to handle it, and they took on board a group of mathematicians. and they try to come up with a great, efficient design or great solution to that nozzle problem. So they were also expert in high pressure systems and fluid dynamics and different chemical compounds. So they created all sorts of formulas, and they held meetings and seminars, and they came up with this intelligent design of a nozzle, but it didn't work. So desperately, Unilever people asked a group of biologists to approach the problem, and the biologists weren't as knowledgeable in physics and fluid dynamics and all those technical things. But one thing they knew is how product or things in nature interact with reality. And what they did is they took that nozzle model and they multiplied it into 10 different variations with slight twist on each of them. So one was a little longer, one was a little shorter, the other had different holes inside, and all sorts of little twists on the thing. And they saw which one worked the most. And that improvement wasn't significant, maybe a few percent better. So they took that winner model or a few winner models and created 10 different variations of those. And then they saw what worked. And then some of them worked better than the others. So they took the best ones and then they created variations of those. And they kept going like this. And with 45 sets of iterations and 449 failed attempts, they created an incredible design that worked and that was way superior comparing to the previous model that they had. So that they approached this problem with let's say, evolution method or method of adaptation and mutation in a way. And that's something that we can take in our lives. This is great examples. Of course, we do not have such huge data sets like Amazon does or other big companies do, but we still can think of this method, this nozzle approach, and those other methods of, if you remember all those examples, basically it's spawning and then selecting the best and spawning and selecting the best in a way. So if we can take that approach and use it in whatever it is we're doing in our sales approaches and techniques, in different project variations that we're launching, in programming, that's the code that we're writing, and all those things, that's a pretty useful way of thinking of things. And those feedback loops are probably one of the most crucial things as far as building something big and significant and have the level of progress that you wouldn't otherwise have. I hope this video has been useful and interesting, and you have a great day or night, depending when you watch this, and see you in the next video.